Dear students, let us see what is there in this question now. Two equal positive fixed point charges, Q is plus 44 microcoulomb and the point P are at the vertices of an equilateral triangle and the distance is also given. So this is basically an equilateral triangle. Okay, and the distance is 0.48 meters. The point P is now moved closer to the charges like this and the distance is x. A point charge Q is negative 2 microcoulomb and the mass of 0.25 kg is placed at point P. Okay, so earlier there was nothing was placed there, but even then the point was moved. Anyways, so this is the mass now, this is the charge now. Now the charge is placed there, and when x is small compared to d, so x is very small compared to d, so I know that he is going towards simple harmonic motion. Why? Because whenever you are doing simple harmonic motion, these are the conditions that have to be there. Otherwise, acceleration is not directly proportional to the displacement. That is why. The magnitude of the net force will be given by this, so we need not to find the force, it is already given. Simple force is directly proportional to x, it is a simple harmonic motion. An uncharged parallel plate capacitor. Again, this is kind of habit of IB, like these are questions, these are complex questions. Many statements, they go together in one single question. So let us skip the statement number 2 and let us directly go to the question right now. So what is the question now? Show that the magnitude of the resultant electric force at P is 3 mega Newton per coulomb. Fine. So we first want to find the total electric field intensity at this point. So what is actually happening? You see, this is the distance, and distance is given as 0.48 meter. So you would be first finding the electric force or electric field, and whenever we want to find the electric field intensity, we just assume that the charge here is unit positive charge. So all are the positive charges, so they will be repelling. So even this charge will be repelling. So what we do, we first find this electric field intensity, this electric field intensity, both are vectors. We are going to create the components like this. This component is going to cancel this component. We are going to add the two vertical components to get the resultant electric field intensity at that point. So let us see how are we going to do this. So E1 can be taken as K Q1, which is basically 44 microcoulomb, divided by, this is the distance R, so it is R square. I am still not substituting the values because there is a bit of derivation, bit of computation that has to be completed first. And then we will try to simplify that, and then we will substitute the values. Till then, we are not going to substitute any value. So charges are equal. I'm not writing it as Q1. It will be Q. So this is E. This is an equilateral triangle, so this is 60 degree. So this is 30, this is 30. These two angles have been divided. So this will be E cos theta. If you know that this is a vector, and this is theta, so this will become E cos theta, this will become E sin theta. So I am interested in cos theta because sin theta components, they are just cancelling each other. So E1 is KQ by R square, and let me call it E1 dash or E1 Y, isn't it? Because I'm concerned with the Y component. So that will be K capital Q divided by R square into cos of theta. Similarly, this E is casting the same component there because the charge value is the same, distance value is the same, angle value is also same. So overall, I can say that the electric field intensity along y-axis will be double this value. So it will be twice of KQ by R square into cos theta. Sin theta is not there. This sin theta component and sin theta component are basically acting opposite to each other. So that is why they cancel each other. We are not considering that. So this is the most simplified form. Now we are going to plug in our values. R is the distance, which is 0.48. Make sure that all of the units are SI, and I have seen it, they are all SI units. So this into cos theta, and theta here is now 30 degree, it is not 60 degree, beware. So it will be cos 30 degree. So we have plugged in these values. We have to now calculate it with the help of calculator. And let me use my calculator now. So it will be 18. I'm having my calculator here on the screen only, I think. Yes. Okay. So it will be 18 multiplied by 44 multiplied by 1000. Cos 30 is root 3 by 2. So multiply by 1.732 divided by 2 divided by 0.48 divided by 0.48. Yeah, so as per my calculation, oh my god, I'm getting a very big number, 2976875. And we will be using mega. So this is 2.9 mega Newton per coulomb, which can be very well approximately written as 3 mega Newton per coulomb. Let us see what is the answer for this first question. It has taken a lot of time for us. Let's go into the mark scheme now. So yes, we are getting the very exact formulation, very exact answer. Fine, very good. Let us now move to question number 2. So the question number 2 is, state the direction of the resultant electric field at point P. Obviously, that will be in the upward direction because positive charges are repelling each other, and at P, we will just assume that there is a unit positive charge. So that will be in the upward direction. So both questions have been completed. Now, next question is, explain why Q will perform a simple harmonic motion when it is released. So we are now going for the question number 3, and it is here. So the force is given by this. F is equal to 115 into x. Clearly, the force is directly proportional to the displacement. Well, there is not a negative sign there, and so you might be getting confused like there is no negative sign. But even then, do not worry about that. You see, now this P is having a negative charge, but this is positive and this is positive. So they are having attractive forces. So these are attractive forces. So overall, the net force is like this. So once it crosses and it goes to this location, the force is now going to change its direction. So definitely, the force which we are creating is definitely negative of the displacement. There is no doubt about that. So we can say that yes, our sine qua non condition, that is the necessary and sufficient condition for simple harmonic motion, is completed here. And that is why we can say that this is going to perform simple harmonic motion once it is released. So question number 3 is also done. Let us go for question number 4. Calculate the time period for Q. Well, it's a highly conceptual question, my dear students, so be very careful. What are we going to do here now? Now you see, so F is equal to negative of 115x. So whenever we compare this thing with simple harmonic motions, don't we say that F is equal to minus omega square x? No, there is mass also. So F is equal to m into A. Yeah, just a moment. Acceleration will be equal to 115 divided by mass into x. So this very thing is equated with omega square, like this, because this is the acceleration and this is the general formula for the acceleration. So we compare this thing. For this question, like we want to find the time period, you have to be good with how to find the time period in the case of simple spring mass system or the simple pendulum. That is given in the theory part in the so course. So you can refer to that and you can see how they are doing. Even in at that time also we were doing like this. We first create this equation and then we say that this thing is equated with the omega square. So clearly omega square is equal to 115 divided by the mass of the charge, which was, I think, given somewhere. Yeah, so the mass of the charge here is 0.25 kgs. So it is 0.25 Yeah, from here we are going to find the uh, we want to find the angular acceleration, angular velocity. What? Oh my god, these questions are so long. Calculate the time period. Yeah, we're going to find the omega here, and after that omega will be 2 pi by capital T square root, and capital T can be found. So this is how we do this question, and I'm not calculating each and everything again. I'm just using the mark scheme for that sake. So I will not be calculating this thing. Okay. So let us go to the mark scheme and see what they have done. My God, these questions are really lengthy. Yeah, so the acceleration is F by m, as I've already told you, and then they are equating with the omega square. From there, they find the omega, and then they are finding the time period. So the calculation cut short, and this is how we do it. And I have explained you exactly in the same manner. I believe there should be no doubt about that. Now let us go for question number 5. What is this graph now? Calculate the time period. We have done this. Yeah. Now at t is equal to 0, the switch is connected to x. Okay. So now the question is going to the statement number 2. And so the statement 2 is here. An uncharged parallel plate capacitor C is connected to a cell of EMF 12 volt, a resistor R, and another resistor of 20 mega ohm is connected like this. So at t is equal to 0, the switch is connected to X. Now you see, so this is the X and Y. Earlier I was thinking like the switch is not even connected and how the current is flowing. So these two switches are now, they are connected. Obviously the battery, the current will start flowing like this. So at t is equal to 0, it is this, and we want to draw the graph of the voltage which is across the resistance R. Okay, so what are we going to do in this? Clearly, the charging of the capacitor is taking place. And when charging of the capacitor is happening, so initially the resistance of the capacitor, like capacitor is also having a kind of resistance, and it resists the flow of the current. Not only the resistance which is placed up here, even the capacitor would be producing some resistance. So this, initially the capacitor acts as if there is zero resistance in the capacitor. So obviously our the current will be maximum, and that will be clearly 12 by R, because the capacitor initially is having zero resistance. But finally, like when everything has taken place, finally the capacitor starts acting as if the resistance of the capacitor is infinite, because at the end of the day the plates of the capacitor are detached. Obviously current cannot keep on moving through it because the circuit is actually broken. So if this circuit is broken, so definitely it is not going like that. So this is infinity. So when this is infinity, definitely the current will become zero. So current is going to start from a maximum value and it is going to become zero after some time. And obviously we know what are the equations for the charging and all that, even that we know. So accordingly we can just create the graph here, and the graph is already created this. So why 12 here? Now you can clearly see, is it coming out to be 12? So this is the voltage across. Yes, so voltage will be 12. Why? Because this is actually not acting. So we can say all of the voltage drop is taking place across the resistance only. So the voltage drop will be 12, no doubt about that. So it will be starting from 12 and it will go to 0. The same is the case with the current, so no worries at all. Moving to the next question, which is the last question for this very long question. The switch is then connected to Y and C is discharging. So now coming back to the circuit, now the capacitor is completely charged. This is positive, this is negative. Now it is connected with Y. Obviously this capacitor will start acting like battery and current will start moving like this. So this process is known as discharging of the capacitor through a resistor. And for this we know that we are using an equation with respect to time constant, isn't it? Like V is equal to V naught e raised to power negative t divided by time constant, where time constant is given by the product of resistance and the capacitance. So we would be utilizing this equation now, and we will find what is asked from us. So they're asking this thing. like the resistance value is given 200 into 10 raised to power 6. The capacitance value, what is the capacitance value? Determine the value of C. So we have to find C. Fine. The time is given as 5 seconds and the value of the voltage drops to 50%. So this will be V naught by 2. It will be V naught e raised to power minus T is 5 seconds here and the time constant. So let us first find the value of time constant. This is half. We have to take the logarithm minus 5 by tau. So this value will be equal to negative ln2. Negative and negative will be cancelled out from this very simple equation. We say that tau is equal to 5 divided by ln2. Well, ln2 value, you can find it from the calculator, but I remember it. It is equal to 0.693. We can plug this value here and we can find. So this tau is equal to 20 into 10 to the power 6. C is equal to 5 divided by 0.693. And accordingly, from this equation, we can find the value of the capacitance. So this is how we do this question, my dear student. Calculation, again, I'm not doing it. And that's it. I believe you people would be learning from the videos that I'm uploading. If there is any feedback, please do share that feedback. All right. Okay. All the best. Bye.